Well, hello. Here we go, kids. 7-3. We're going to talk about polynomials and angles and coordinate proofs. All three of those things. Here we go. Polynomials. Lots of different names here. You probably know most of these. What do you call a three-sided? Let's see if I've got these in the right spots here. 4, 5, 6, 7, 8, 9. Let's say those 10. Do you know the names of a four-sided? Why, yes, Mr. Larson, we just finished a number of sections dealing with quadrilaterals. Pentagons, hexagons. Do you know what an 8-sided one? 9, 10. Hopefully you know those words. Octa, nona, deca, and then add the word gon. First question we need to ask ourselves about these polygons if we are going to be focusing on the angles in a triangle. We need to ask ourselves, how many triangles are there in a quadrilateral? Well, if from a vertex, key thought here, right? Pick a vertex, draw the number of diagonals from that vertex, doesn't matter which one you pick, but only pick one, and you can break it into two triangles, all right? I'll zoom in here. Here is my, here is my quadrilateral. If I pick a vertex, bam, two triangles. Now I can draw more, but anytime you pick a particular vertex, we can only break it into two triangles. Pentagon, 3. Hexagon, 4. Oh, what's happening each time? We are subtracting 2. Why are we subtracting 2 every time? Hopefully you can see a reason there. How do I get the total degrees? This would be the sum of the degrees in each triangle. Well, for a triangle, you know it's 180. Sorry, for a quadrilateral, you may or may not know, but for a triangle, you know it is 180. So 2 times 180 is 360. So 3 times 180 is 540. So we can find all of these. And it's nice to have this little chart written out for all of those so that you know how to, you can reference it. You can always do the math and figure it out, but know your Latin. Are these Latin or Greek? I'm not entirely sure. These roots here. Quad, penta, hex, hepta, octa, nona, deca. All right. What is the formula? What is the theorem regarding the interior angles of a triangle? Well, if you have a polygon and you have n sides, then to get the sum of the angles, we'll call S. You take the number of sides, you subtract 2, and you multiply by 180. All right? Let me make sure. Okay, so to find the sum of the individual, so each interior angle, and this would need to be on a regular, please write the word regular below it, meaning all the angles would need to be congruent. Then you would do the same thing, n minus 2 times 180 divided by however many sides you have, or how many vertices you have. All right? Exterior angles. So if we take a polygon, here I've got a pentagon, and I add up all the exterior angles, okay, on a pentagon. No matter regular or non-regular, right? Whether they're the same or not. Oddly enough, there's no formula. It's just a constant. And the theorem will say the exterior angles will add up to 360. I did it here. We'll do this in class, but here I have a pentagon drawn. you could do the same exercise with a hexagon. And if you notice, I've highlighted each of those angles. Now, if I go to the algebra and I look at those each angles, so for example, angle alpha is 77.6. I'm trying to find alpha. There's alpha is right. I'm moving alpha. Yeah. So now it's 82.4. And if I add each of them up, right down here at the bottom, you can see that it says the sum of those is 360. And it is an approximation. The computer's doing the best job, but we know that it has to be precisely 360. I'm going to come back to coordinate proofs. We'll do that last. So the sum is 360, always. Boom. Make sure you have that down, okay? That is a theorem, but we use it more like a rule. How do I get the number of diagonals in a polygon? We did this a while back. It was one of the exercises. You might have forgotten it by now. But to get the number of diagonals, I should actually spell out the word diagonals here. Let me do a quick switcheroo on you. Then we take n times n minus 3 divided by 2. All right. So the problems are going to come to you, and they're going to say something like this. It says, in what polygon is the sum of the measure of the angles, one vertex, equal to the sum of the measures of the angles of the polygon? Wow, lots of things there, okay? So let's break it down. Look at the parts. So it says, first of all, in what polygon is the sum of the measures of the exterior angles, one per vertex, equal to the sum of the measure of the angles in a polygon. So I want the interior sum equal to the exterior sum. You could do this by trial and error, but we could also do it in a little formula. Yeah? We know the exterior sum is always 360. We know the interior sum, if I go back to my formula, we take n minus 2 times 180. And now I say solve this, and this will tell me how to get that. So to solve it, again, we would divide by 180. And we would get n minus 2 is equal to 2. Add 2 to both sides. And now notice we have n equals 4. What type of shape is this? This is a quadrilateral. All right. And then it says, in what polygon is the sum of the measure of the interiors equal to twice? So the measure of the interior angles equal to twice the measure of the exterior angles. So again, n minus 2 times 180 equal to twice. Solve it again, you'll get an answer. Bam. All right. Last thing we need to go through is the toughest idea, and it's coordinate proof. So please write this down. Pause the video if you're watching the video, and copy down this particular diagram. We're going to prove the diagonals bisect in a parallelogram. This is something we know from a characteristic, but we never really proved that they bisect. So today we're going to prove that. We have 4 points, A, B, D, C. Yeah? There's the bell. Don't worry. Keep going, kids. Okay, so the coordinates of B. I don't know how far over B is, so I'm just going to say A, comma 0. Okay? This distance is A. Then I'm going to say how far over is C, and how high up is D. Well, D, the easier one is the height. How far over is A? You could come up with a new letter and put that there, because we don't really have a letter for this distance. But do we? Notice I know this distance, which is right here. right? So because this distance and this distance are the same, and this distance, right, together make up that, then I can say, oh, A plus B. All right? Okay. So now, whoop, using these coordinates, we're going to do that. To do that, we're going to show that the midpoints match. Meaning, I'm going to find the midpoint of DB and the midpoint of AC, and they'll be the same thing. All right, midpoint of AC. All right, remember to find the midpoint, it's the average point. So I'm going to draw, yeah, and I'm going to say I need to add up two things, divide by 2, comma, add up two things, divide by 2. Add up two things, divide by 2, comma, add up two things, divide by 2. So for A, I'm going to add those two things. Notice I get A plus B plus 0, which is just A plus B. And then again, I take the y coordinates, same thing, 0 plus D. Please always show your work in these problems. Show what you're doing. B plus A divided by 2, and D plus 0 divided by 2. Now notice, we now have, I will be with you shortly. I'm doing a little video, okay, which you are now featured in.
Yay.
Hi, students.
Hello.
A plus B divided by 2, and it is my lunchtime. All right, so notice we've matched these two things up. Therefore, these two have the same midpoint. They bisect each other. They cut each other in half. Okay? All right.